Okay, so let's have a look at the Junior Certificate Higher Level Maths Paper 2 for 2019, questions 8 and 9. So here in question 8, we have a net and it can be folded to make a fair die. What number would be opposite the number 7 on the die? So you can see here this is number 7. And if you fold this one, fold this one, fold this one over along here, you'll see that it's actually going to be opposite the number 1. Our answer here is just going to be 1. Okay, so second part of this question then is the die is rolled once. Find the probability that the number rolled is greater than 6. Well, we have 1, 2, 3, 4, 5, 6 sides to our die. So it's going to be something over 6. So our answer here is just going to be something over 6. And how many numbers do we have greater than 6? Well, we have a 7 and an 8. So we have 2 numbers greater than 6. So our answer here is just 2/6 or 1/3. So that's the probability of, find the probability that the number rolled, this is going to be the probability that the number rolled is greater than 6. Okay, so looking at part C here, we are asked to work out how many times you would expect an odd number to be rolled if we roll the die 60 times. So we have 6 sides here, so it's going to be something over 6 is going to be the probability of rolling an odd number. And we have 1, 3, 7, and 5 are our odd numbers. So 1, 3, 7, and 5, so we have 4 odd numbers. So the probability of rolling an odd number is going to be 4 out of 6. We have 60 rolls of the die, so that's just going to be 40. So that's going to be the number of times we would expect to get an odd number when we roll the die 60 times. So that's the what's called the expected probability of getting an odd number, 4/6 of 60. Okay, so let's have a look at part D then. The following 3 terms are used when discussing experiments in probability. So we have an outcome, we have a sample space, and we have an event. Write each of these terms in the table below to match each term to its description. So the set of all possible outcomes of an experiment. The set of all possible outcomes of an experiment is just called the sample space. One possible result of an experiment is just called an outcome. And a subset of the sample space, a collection of one or more of the outcomes, is just called an event. Okay, so that's question 8. So let's have a look at question 9. We have Ger who flips a coin 3 times. Each time he can get a head or a tail. The diagram in the table below shows how he can get each of the 8 different outcomes. Complete the table below by doing each of the following. Write each of the missing letters H or T in the diagram. So let's do that first anyway. So we have first flip is here, second flip is here, third flip is here. So we got to fill in these empty boxes here. So the first flip he can get a head or a tail. Second flip he can get a head or a tail here, given that he got a head or a tail the first flip. And he can get a head or a tail here, given that he flipped a tail the first flip. Here we've got heads, tails, we've got heads, tails, we've got heads and tails here. So the second part of this then just asks us to write the 5 missing outcomes. So if we have a look here, we have head, 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 we have head, head, tail. If we take this route here, head, head, and then tail here. And then down here, then we've got head, tail, tail. Along here then, if we take this route here, we've got tail, head, head, tail, head, head is here. If we go along here, then we can see we got a tail in the first flip, a head in the second flip, and a tail with the third flip. So here we're just going to write in tail, head, tail, tail, head, tail. Down along here we've got tail, tail, head. And down along here we've just got 3 tails. Now that in our last column here, I presume they're going to ask us about this as well. Write the number of heads in each of the outcomes, so the number of heads. So let's have a look at that. So here we can see we have 3 heads here, head, head, head. Here we've got 2 heads, so we're just going to write a 2 in here. Here we have 2 heads, so write 2 in here. Here we've got 1 head, 2 heads, 1 head, 1 head, and no heads down here. Okay, so let's look at part B. So it says each outcome is equally likely. Fill in the table below to show the probability that Jar gets each of the given number of heads. So the probability that he gets 0 heads. Well, the total number of outcomes are, let's see, 1, 2, 3, 4, 5, 6, 7, 8. And the number of times he gets 0 heads would be once, so that would be 1 out of 8. So there's 1 time out of these 8 that he will get no heads. So our probability here is 1 out of 8. Here, how many times can he get 1 head? Well, I can go 1, 2, 3. So here it's going to be 3 out of 8. How many 2s are there? Well, there's 1, 2, 3. Again, 3 out of 8. And how many 3s are there? Well, there is just 1. I think 3 heads. Yeah, 1 out of 8 here. And that's it for part B. Okay, so in part C, Fidelma flips a coin 8 times. Each time she can get heads or tails. Write down the number of outcomes that have no heads. Well, there's really only going to be 1, and that's the outcome tail, 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 tail. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. It's going to be that outcome there. And there is only going to be 1 of those. Write down the number of outcomes that have no heads. Our answer here, so our answer here is just going to be 1. There's going to be 1 outcome where there are no heads, so just all tails. Work out the number of outcomes that have exactly 1 head. Well, if you take the first possibility might be this here, head, you might get a head the first time, then a tail, 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 and tail. Let's see, 1, 2, 3, 4, 5, 6, 7, 1 more. That would be 1 possibility. The next one would be, you might get a tail the first time, then a head, then a tail, 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 and tail. I think that's 1, 2, 3, 4, 5, 6, 7, 8. That's another possibility, and so on. You might get a tail the first time, tail the second time, then a head, then tail, 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 and tail. So it keeps going on like that until you end up with the head here out here, the last flip. So the number of outcomes that have exactly 1 head. So our answer here would be 8. There are 8 possibilities where you have 1 head, flipping the coin 8 times. Okay, work out the total number of outcomes when Fidelma flips the coin 8 times. Okay, the total number of outcomes. Well, that's simply given by 2 to the power of the number of times that she flips the coin. In this case, it's going to be 2 to the power of 8. So 2 to the power of 8 is 256. 256. Another way of looking at this is, let's say, if you take the first flip here. So this is the first flip. You can get a head or a tail. So how many outcomes have we got? We've got 2. That's 2 to the power of 1. If you go again, second flip, you can get head, tail, head, tail. This is the second flip. So how many outcomes have we got now? 4. That's 2 to the power of 2. That's 2 flips, and so on. You've got 1, 2, 1, 2, 1, 2. So here we have head, tails, head, tail, head, tail, head, tail. So this is the third flip. So how many have we got here? 2, 4, 6, 8. We have 8 possibilities here, and that's 2 to the power of 3. This is 3 flips, 2 to the power of 3. So if we continue that on, 2 to the power of 8 flips will give us 256 possible outcomes. And that's it for these questions.